Hi, everyone. This recording is to serve as a supplemental asynchronous session walking you through the introduction to SPSS. I know not all of you have been able to get um, SPSS on your home computers, and so I thought it might make more sense for you to be able to go through this once you have it available. We're going to do a little brief overview of quantitative research in terms of the statistics that you might produce. And then I'm going to show you how to open up data files in SPSS, walk you through what the program looks like, and then walk you through some basic analysis. Following this, I will post some ungraded practice assignments on Brightspace for you to work through some of these activities and statistical modeling on your own or in groups, whatever you're more comfortable with. So first, let's do a little bit of discussion on quantitative research. Right. So we talked a little bit last week about the approach to research design in quant and in the quant space, and about how it tends to be focused on testing hypotheses or addressing your research questions in a more systematic way. And in doing that, in testing your hypotheses or addressing your research questions in the quant methods space, you end up being able to either support your theoretical framework, amend it, or refute it. And you do this by taking data and summarizing it. At the most basic level, this involves looking at variables, right? These are the constructs that your data collection instruments measure, right? For example, if you were designing a survey and the survey had 10 questions, those 10 questions would likely translate to 10 variables. From the variables, we move to this notion of simple statistics, which we will talk about in a second, but a lot of this will be familiar to you. This includes things like mean, median, mode, frequencies, describing the data you have using simple counts and proportions. Beyond that, you can move to effect statistics, looking at the relationship between two variables and determining if that relationship is positive or negative. As one goes up, does the other go up? In terms of thinking about like height, as age goes up to a certain point, height also goes up, right? 5-year-olds tend to be taller than 2-year-olds. And also whether or not something causes another. From there, we move to simple statistical models like analysis of variance, which we will talk about in this class, to then the more complex, which would be more complicated regression models where, for example, you're trying to predict whether or not somebody voted in an election. And those would be covered in the advanced quant space. The summarizing of the data is in service of this notion of generalizing from your sample to your population, which is why in quantitative research and in quantitative research design, the sample that you need to get information from needs to be of a certain size. The idea here is that you're taking a representative smaller group of people from the larger population, and you want to have enough people in that representative sample so that you can be sure there isn't bias. So unlike in a qual study where you might interview 10 teachers from the Hudson Valley region, for example, so that you can understand their experiences. In a quant, the idea would be to get data from a large enough sample of Hudson Valley teachers so that you can actually generalize those findings to the broader total population of teachers. When you create a sampling plan that gets you a sample that allows you to do this, you have a greater precision of estimates. You work through things like confidence limits and intervals, statistical significance, and p-values, which tell you the statistical significance, and you also calculate a degree of error. All of this is common practice in quant and would not be included in qual. Your data are a set of values on one or more variables. I say set of values because the key piece about a variable is that the information included on that variable needs to vary, right? So a variable is something that has different values. Values can be names, they can also be numbers. So there are inherently non-numeric variables. They tend to be nominal variables, things that do not have any numeric definition to them and also have no rank or order. Gender is a nominal variable. There is no rank order to female versus male versus non-binary. Race, ethnicity is a nominal variable. Those are different categories that describe that identity. There is no rank order to them. No one group is better than the other. From nominal, you move to ordinal. These can still be categories, but there is an inherent order to them. So highest level of education measured in the degree that you have has an order to it, right? If you are measuring highest degree earned, and the responses are high school diploma, associate's degree, bachelor's degree, master's degree, doctoral degree, those categories are not inherently numeric. First of all, it can take people different amounts of time to achieve each of those, right? But there is a rank order to them. An associate's degree requires more education than a high school diploma. A bachelor's degree requires more. There's also some notions around the prestige of those degrees. So that is an ordinal variable. Then there are counting variables. These are numeric in nature. These have a rank order to them, right? Number of natural disasters, number of times you exercise in a week, and then numeric. These are things, again, that are also inherently numeric and quantifiable and have an order, but it's not simply a count. The year you were born, for example. Okay, so when we work in SPSS this term, we will be working on a data set that contains a number of variables. Okay, so a quick note on SPSS really quickly. I am going to show you both the data file in SPSS. I will also show you what's called the output file, which is where the results of the tests you run are printed and produced. And I'm also going to show you a syntax file. You don't have to work in a syntax file, but it can be really helpful. This is a file that essentially has the code that tells the program what to do. Okay, SPSS also has some nice drop-down menus, which you will see that we will work through. But I think a syntax file can be helpful for when you have to go back and do something again, just in case you forget. You can also put comments in your syntax files, which I will show you. This allows you to keep a log of all your changes and your updates. If anybody throughout this process needs some help reminding themselves, or learning how to interpret SPSS output, the UCLA Statistics Department does have a nice repository where you can look up annotated SPSS output for different tests. It has a menu. You can look at data analysis examples, annotated output. The annotated output in particular is useful because what it provides for you, so this is a descriptive table. We will produce a table just like this many times in this class. In SPSS, though, it doesn't give you essentially footnotes defining what each of the statistics are. The UCLA website will annotate the output and, for example, define what the N is, that's the total sample size, what the minimum, the maximum. If you forget what the standard deviation is, they will provide the definition for you. Okay, we will go through all of that more formally in class once we move into statistical analysis and testing, but this is also just a helpful tool to have at your fingertips. Okay, so moving to the sample data, which is available on Brightspace. We are using the NLSY 97. This is a publicly available data set that is housed by the Bureau of Labor Statistics called the National Longitudinal Survey of Youth. This data set is of the 1997 cohort, which follows a sample of Americans who were born between 1980 and 1984. In 1997, the first round of data collection, these respondents were between the ages of 12 and 17 years old. The study followed them annually, right? The data set that you guys are using will have roughly 19 rounds, but there have been subsequent rounds to that. So it asked them survey questions about their education, their family, their household, their health, both mental and physical, certain practices, their hobbies, starting when they were between the ages of 12 and 17 and following them annually. So as you can imagine, the context of the questions also changed across that time because the ages of the students changed. It allowed the researchers to look longitudinally at this group of young people and look at, in particular, life transitions. The transitions from middle school to high school to college, college to employment. The initial questions that asked about your household composition were directed at kids, so they probably spoke about their parents or other guardians and caregivers they lived with, maybe siblings or extended family. 10 years later, that might have included roommates or significant others or their own children. Questions about income, assets, program participation, fertility, pregnancy, as well as crime and substance use and abuse. It tracks whether people have had contact with the criminal justice system, whether they were arrested, convicted, incarcerated, attitudes, expectations, political opinions, things like that. The sample is comprised of 8,984 Americans. It is a representative sample. That 8,984 demographically breaks down in a way that mirrors the US population. It's roughly 50-50 male-female, 51% male, 49% female. It is 52% non-Black, non-Hispanic, 22% Black, non-Hispanic, 21% Hispanic, 0.9% mixed. Now, the survey's goal was to follow all 8,984 students every year into adulthood. But realistically, people drop out for various reasons. Perhaps they are deceased. Maybe they were incarcerated. Maybe they simply didn't want to participate anymore. Maybe they moved and it was hard to find them. Because this was a nationally representative survey conducted by a federal agency, there were a lot of resources to support it. So every time someone dropped out, they outreached to replace them with a new respondent who was demographically similar. So if myself, who between the ages of 12 and 17 were a white female who was living in a single parent household in suburban New Jersey, dropped out, they would have found another white female living in a similar geographical region, ideally with similar household characteristics. For the purpose of this class and the sample data set, we are going to look at a subsection of the variables. There are demographic variables in there, including sex, date of birth, citizenship, race, ethnicity, parents' highest level of education, marital status, religion. There are some traditional academic achievement variables in there, SAT scores, GPA, highest degree earned. There are some employment variables. There are some income and asset variables. There's also a question about whether the respondents have donated to a cause. We will look more in depth at this data set throughout the semester. I will also post the code book for the data set. The code book, sorry, is posted on Brightspace under course materials. So under content, you want the course materials and you want the data SPSS folder has the code book. Okay. Right now, what we're going to do is we're going to open data. We're going to look at the different views, variable view, data view. We're going to open a syntax file. I will show you guys the code book. And then we're going to work through a couple things. One, we're going to work through renaming and labeling variables. We're also going to talk about creating new variables. And then I'm also going to show you how to do some basic statistical analysis. This set of slides tonight has screenshots, and these are posted on Brightspace. In a second, though, I'm actually just going to move into the program so you can see it. If you feel like it's easier to just have SPSS open on your computers and watch the video and work through it, that's one way to do it. Another way would be to have the notes from class with the screenshots open on it to look through that as well. I will leave that up to you. So the first thing I'd like to do is open the data file. So the one key thing to remember, and I apologize, this is a pretty simple thing, but you'd be surprised how often this creates problems. If you do not have SPSS downloaded on your computer, you cannot open an SPSS data file. Macs, PCs don't know how to read those files in any other format. Certain Microsoft Office files like Excel or Microsoft Word can be read in notes applications or text applications. SPSS cannot be read in anything else. So if you do not yet have SPSS on your computer, you should just be kind of watching along with the video. If you go to Brightspace and you go under the content for the course and you go into data/SPSS, there is a data file labeled NLSY97. That is the data file that we should be using. You can download it from Brightspace and then open it. There is also in that same folder on Brightspace, the NLSY97 code book that you should also have open. Right now, I'm going to share my screen again, and we are going to go into SPSS. So here is SPSS. This is the NLSY, as you can see, 97 data file. Okay. There are three kind of button tabs at the bottom. What you will likely be most concerned with are either the data view or the variable view. Okay. So the data view is your raw data file. The information across the top are the variable labels. The information down the rows are the responses on those variables. Each of these variables correspond to a question in the survey. The variable view lists each column of information in the data set. So the rows in the variable view, as you see here, row 1, R00000100, corresponds to the first column of data in the data view. So this simply is the unique identifier. This is the public ID. This is a randomly assigned ID number for each respondent in the data set that stays consistent across each round. This allows the researchers to connect each year's data to the previous years. This is also a way of distinguishing respondents from each other without including publicly identifiable information. So rather than it saying Nora Broge, for example, I might be public ID respondent 1. Okay. The second row in the variable view, R0536300, which is labeled the respondent's sex, gender identity, corresponds to the second column of data, right? So in the variable view, you have a name. This is what is listed at the top of the columns in the data view. You have a label, which essentially defines what that variable is. Right now, you don't have any values, but we will talk about that in a second. You have this column labeled missing. This is telling you if there's any missing information in the data set and how it is labeled. We'll talk about this in a second. Sometimes there's information missing in a data file because someone skipped a question. But sometimes there's information missing in a data file because it makes sense for it to be missing. For example, if question 1 of the survey is, do you have children, yes or no? And I say no, then I should not get a series of questions asking me how many children I have and how old they are. But if somebody else were to say yes, then they should get a series of questions asking them how many children, how old are each of those children, right? So the person who doesn't have children would be missing on all those detailed questions describing their children, how many there are, how old there are. And so this is just a way of kind of numerically acknowledging that and also telling the program not to include those people in analysis. So I want to show you guys another thing really quickly. And what I'm going to do that is I'm going to open the code book, which will also put quite a bit of this stuff in context. So the NLSY code book, which is also on Brightspace, as I said, simply describes all of the variables and the information that you have in your data file. Okay, so here's the code book. For each variable, the first one being ID, right? It gives you the total number, the N, the sample size. It also gives you some statistics on this, but for an ID number or name, that isn't really relevant. Then, for example, for the next variable, though, the code book is quite useful. So for the sex variable, right, there are 3 possible responses, 3 valid values, 0, no information, 1 corresponding to male, and 2 corresponding to female. So this code book table for this variable sex tells us a couple of important things. The first one is that there's no missing information on this variable. Every respondent identified themselves as either male or female, and this is the breakdown of the sample according to those identities, right? Similarly, for date of birth month, right? The date of birth month variable is coded from 1 to 12. Each of those numbers corresponds to a calendar month, January through December. This is how the responses break down for that one. Date of birth year, right? This is input, person put the year in. Again, there's no missing information here. You see the N valid, 8,984, 0 missing. Now, the next variable is citizenship. There are 3 possible responses for this. There is a citizen born in the United States, unknown not born in the US, and unknown can't determine place. What's interesting to note about this variable, though, is that there is missing information. Of the 8,984 respondents, roughly 1,042 people did not provide a response for this. Okay, so you don't have a complete set of data here. Okay. As you go down, this continues to tell you other variables. Dad's level of education, which is measured in years, right? Which goes from 0, no education, all the way up to the 8th year of college or more, which would presumably either be someone taking a very long time to get out of undergrad or someone with some graduate training. Mom's level of education. Again, both of these variables contain missing information, right? Of dad's ed, 1,856 people don't have a response. Mom's ed, 688 people don't have a response, right? Here's your race ethnicity variable. These are the numeric values, and they correspond to these categories: Black, Hispanic, mixed race, non-Black, non-Hispanic, SAT verbal, SAT math, all the way down to the end. So the code book not only gives you a sense of the variables, how they're defined, but also how they are labeled, and also tells you some information about how much of the data is complete versus missing. Now, in a data set this big, 8,984 people, if you're missing 688 people, that's not a big deal. You still have well over 8,000. If you're missing 2,000 people, that's still okay. You have well over 6,000. That's why quantitative research needs to rely on much larger sample sizes, though, because sometimes you don't get complete data and information from everybody. Okay. And when that happens, you need to make sure that you still have a large enough sample size to continue. Okay, so let's explore the data a little bit. The first thing I want to show you how to do is just simply look at counts of the data. When you have non-numeric variables, variables that are nominal, remember these are categorical variables with no order, like gender, sex, race, ethnicity, religion. A mean or average statistic is not possible and wouldn't actually make any sense to compute. So when you try to describe the data that you have using a descriptive statistic in that context, you want to look at what we call a frequency statistic. So let's walk through how to calculate frequencies. So there are at the top of the SPSS window, there is a menu, a toolbar menu. All of the statistical analysis, anytime you are computing something, whether it's a simple count all the way to a correlation, you are going to be using this analyze menu. Okay. If you are cleaning data, manipulating data, transforming data, then you might use the data menu or the transform menu. But anytime you are trying to understand what the data looks like, whether that's by looking at the distribution, you're going to use this analyze. Your simple statistics or descriptive statistics are under the descriptive statistics menu. And the first thing we're going to look at is a frequency. So we're going to go analyze, descriptives, frequencies. Okay. You will end up with this dialog box. You can put as many variables as you would like in the list. I will say this though, and you will see this illustrated very clearly in a second. A frequency table is going to yield counts for every response on that variable. Okay, so if you have a question that could have hundreds of different answers to it, a frequency table may not be useful. Okay, it's going to be a very, very long table. If you have data in a data file that has a smaller, manageable number of categories, a frequency table makes a lot of sense. For example, let's look at sex. We can also look at whether or not someone donated to a cause in the last year. To move these variables back and forth from the full list to this box, which is telling SPSS to run the frequencies on those, you use this arrow in the middle, or you can simply double click. Okay, so we'll do key sex and donated to a cause. If you click on statistics, a new dialog box will open. You can see that in the frequency stats, in addition to the counts, it can also give you the mean, the median, the mode, and distribution variables as well. It can give you the minimum and the maximum. For now, let's just simply look at the counts. Okay, so we're going to leave this blank. Can leave everything else blank. Now, if I click OK, an output window will open up with a table that has the frequency statistics for these two variables. If I click paste, instead what is going to happen is that a new syntax window will open up. Remember I said you can work in a syntax window and you can save this. So you could say like intro to quant, session 2, SPSS introduction. Okay. As long as a line has a period at the end, it SPSS will know to go to the next line. If you want to put notes in, I would recommend putting some asterisks at the front end. You see how all of a sudden the color of the font changed from black to pale gray? That's because the asterisks are telling SPSS this is not command. This is not code to produce something. These are just my notes, okay? Dataset activate is telling it what dataset you're working with. If you wanted to put some notes in here, you could be like code to calculate frequency tables or sex, gender, and whether donated to cause, period. Okay. To run the syntax, you simply highlight the command, which will start with a statistical test or command like frequency descriptive regression, and it will end with a period. So highlight that row and then click this green arrow at the top. Okay. Once you do that, your output window will open, and included in that output window will be the frequency tables for those two variables. So let's give it a second while it is processing this. What you are going to see in the output window right now is exactly the same as you would have seen if you had gone analyze, descriptives, frequencies, and instead of clicking paste, if you had simply clicked OK, you would have gotten the same thing. All right, so I'll just demonstrate that. So if you click OK here, right? So I'm basically getting the exact same thing produced twice. So at the top, here is a log for each of these two variables. As you noted in the code book, the variable identifying respondents' sex is complete. It has 8,984 respondents. Nothing is missing. This next variable, which is simply a yes or no question, whether or not you donated to a cause in the last 12 months, is not complete. There are 2,038 people who did not answer. Okay. So this top table, this is our sex variable, right? 1, if you recall from the code book, is equivalent to male, and 2 is equivalent to female. These are the raw counts: 4,599 males, 4,385 females. This is the percentage that raw count accounts for: 51.2% male, 48.8% female. Now, on the donated to a cause in the last couple months, 5,063 people, or roughly 56%, said they had not. 1,883 people said they had, which is roughly 21% of the total population. And another 2,038 did not respond. Okay, so you'll note that in this case, there's missing data. The missing is labeled accordingly here. So there's a reason it's missing. Maybe they were unemployed. Maybe they purposefully skipped the question. Maybe they intended to, but it didn't work out. As a result, there is a frequency, a percent, and a valid percent, and the percent and the valid percent are not equal. So up here in the sex question, because everybody answered the question, the percent and the valid percent are the same. The percent of people who said males is 51.2% of the total people who responded to that question, which is also 51.2% of the total people. In the donated question, though, the percent, 56.4%, is actually the percentage of the total population, the 8,984, right? So that includes the people who didn't answer. When you are talking about the percentage of people who told you whether or not they donated to a cause, you don't want to be looking at the total sample of 8,984 because not everybody gave you a response. You only want to look at the sample who gave you a response. So you only want to look at the 6,946. And of that group, 72.9% did not donate. And 27.1% did. Okay, so this first set of tables is from the syntax file. This second set is from the dialog box, identical. Now, this is helpful, but you may not always remember what the codes are, and you might not want to keep flipping back and forth with your code book. So what you can do is, in your data file, in variable view, right? You can go back into the variable view. You can also look at the data view, right? So if you remember, our first column is the ID number. Our second column is the variable that respondents used to identify whether or not they were male or female, right? Which is right here. What we're going to do is we're going to change the values to correspond with the labels. So let's go back to our code book for a second, right? And you see at the top of the code book, 1 corresponds to male and 2 corresponds to female. 1 corresponds to male and 2 corresponds to female. Meaning, everybody in this second column, R0536300, everyone who's a 2 is a female and everyone who's a 1 is a male. So let's go into variable view. Under values, click the 3 dots. A value labels dialog box will pop up. Click the plus. You're going to put 1 male. Click it again. You're going to click 2. And then under the label, let's do all cap. Female. Click OK. Once you do that, now we have value labels for this variable. Okay. And if we were to again run the frequency table on that same variable, sex, we will actually see a difference. Instead of 1 and 2, we now see male and female. So it's just another way to clean up the data and make it easier for you to quickly reference categories. Now, in a variable like sex where there's only 2 possible responses, it's pretty easy to manage without the value label. But in something that might have 10 different responses, this can be easier. So again, that all gets done in this values space. So when you want to change the values again, you go into the values column, click on the 3 dots corresponding to the variable. When you want to add something, you press the plus. If perchance you messed up or there's a typo and you want to get rid of something, you can just press the X and it goes away. I'm going to put that one back though. So you put the numeric value under value, and then you put the category label under label and click OK. I'm going to post on Brightspace to work through adding the values for a couple of other variables as well. Now, the current variable identifying sex is coded as a 1 for male and a 2 for female. But as we move towards different types of analysis, instead of having that continuous variable, it might make more sense to have what we call a dummy variable. A dummy variable is a binary variable that has 2 categories that are represented as a 0 for not being that category or a 1 for being that category. So a dummy variable for male, therefore, would be coded as 0 for everybody who is not male and 1 for everybody who is male. A dummy variable for whether or not you had kids would be coded as 1 for if you had kids, no matter how many, and a 0 if you didn't have any kids. You create those variables just like you create any new variables by using this transform menu. So you go transform, compute variable, and you're going to basically tell SPSS to create a new variable, to add another row in the variable view. So right now there's 48 rows. We're going to basically tell it to create a 49th. So we're going to call it male. We're going to say it's equal to 1. Because remember, dummy variables are coded as 0 or 1. If, okay, everybody who identified themselves as male in the original variable, like that's who you want to pull in. So you're going to say this new variable labeled male, called male, is equal to 1 if the original sex variable is coded as 1. You're going to click continue. Okay. You're going to click paste. Right, and we'll go back to our syntax folder, right? So now we're going to be working in the syntax file to be generating the syntax or the code to create a new variable. Okay, so we're going to put another label in our syntax file. Say code to compute new dummy variable male equals 1 if male equals 0 if female. Okay, so here is the code for that. We're going to highlight that and run it. Okay. In our data file now, which used to have 48 variables, there is now a 49th. Okay. This variable is coded as 1 for those who are male. So if you look at the data view, right, row 2 here is a male. At the end of the data set, also male. Now you'll note this new variable male has empty spaces. That's because we told it to pull all the people who had responded that they were male in, but now we have to pull the female. So for that, you're going to go back to your transform window. You're going to do recode into same variable. So that's transform recode. Okay. You're going to scroll to the bottom and select male and pull it in the variable window. Then select old and new values. The old value is missing, right? Empty cells are missing. And we're going to change that to a 0. So the old value, select system missing, the new value, value 0, and then add that. Okay, click continue, click paste. So in our syntax file, we now have to compute the variable, the new one, male equals 1 if the old one equals 1, and then to recode it. So I'm going to put that too. Code to recode new male variable and pull in female respondents and equal to 0. Okay, so now we're going to highlight that. If you go back into the data view now, that variable male has 0s and 1s. Okay, so we're going to go back into our variable view. Let's put the values in there. So click the 3 buttons. I'm going to say 0 is female. 1 is male. Okay. Okay. So now we have zeros and ones. When you compute a new variable, a dummy variable in particular, it's always a good idea to check that you've done it correctly. And there's another type of descriptive statistic that you can use to do that, and that is called a crosstab. So we're going to go back to our analyze descriptives, and let's come down here to crosstabs. A crosstab is essentially the counts of one variable against another. So it puts one variable in the rows and another in the columns, and it shows you how the data distributes across those rows and columns. So this is not to see kind of what the breakdown of marital status is by gender, for example. This is to check that the new variable that you created is correct. So we're going to put the initial variable sex in the row and the new variable male in the column. Okay. Now for something like this, the simple counts alone will work. But what is sometimes helpful is in the cells button. So as you see in the main dialog window here, I clicked cells and select row, column, and total. This will not just give you the count, but also the percentage, which I will show you in a second. So we're going to click continue. Let's do that paste again. Okay. So now we have, I'm going to put a note in here, code to compute cross tabulation for old sex variable and new male dummy variable, period. Okay. So again, we're going to highlight the code, click the green arrow, and we are going to end up with a new table at the bottom of our output file. And this table will not just have frequency counts for one variable, it will have frequency counts for one variable as it distributes across another. Okay, so this is useful when you're trying to kind of describe subsamples within your data set, right? So let's say you start by exploring your data and looking at the number of men and women and the proportion of men and women, but then you want to take it a step further and see how many of those men are white versus non-white. A crosstab is useful for that. So in this case, again, we're just using it to kind of confirm that what we did was correct. So as you can see here, across the top row is the new variable, male. 0 for female, 1 for male, right? Along the first column, going down that column, is the original one, which has the sex variable. And I did just notice that for some reason our labels are off. So let's go back just again. Let's go into our data file. Yeah, for some reason, so let's go back into our values. Let's just make sure this is here. So again, this was 1 for male, 2 for female. Okay. All right. And now we'll go analyze, descriptives, crosstabs. All right, so we already have the syntax pasted. So from here, I'm just going to click OK. All right. Now, as you can see, all right, so if in fact we computed the new variable correctly, the count comparing males to females should be 0. So female, 0, male, 0, right? So the original variable, sex, the 4,599 people who said they were male, in the new variable, they are in the male column, right? The 4,385 respondents who initially said female on that sex variable, they are only included in the female category here. Okay. So this is just a check to make sure our new variable is correct. Another way, though, to highlight this, right, would be to look at a crosstab for a slightly different variable. So let's look at a crosstab looking at who donates to causes. So we're going to keep our new male variable in, and let's click donate to a cause in last year in the row. All right, let's click OK. Now this tells me the number of women who donated to a cause in the last 12 months was 1,094 versus the number of men, which was 789. So I know that they are women because they are in the female column on the male variable and in the one row on the donated. Remember, it's did you donate to a cause? 0, no, 1, yes. So 1,094 women versus 789 men. So this could get, if you were trying to describe who's charitable by sex, gender identity, a crosstab could help you get there. Again, both frequencies and crosstabs are simply telling you raw counts and how those raw counts break down into proportions of your total sample in the data set. Okay. Moving forward, I'm going to post, as I said, on Brightspace, some questions for you to examine, looking at frequency tables as well as crosstabs for a couple of different variables. Okay. The next thing I want to do is I want to move to the other broad category of descriptive statistics that moves beyond simple counts and proportions. And those are in SPSS referred to as descriptives, but in statistics, they are referred to as measures of central tendency. Okay. So you may recall from a statistics class in the past, you may recall from a methods class in the past, you may recall from algebra. Your measures of central tendency describe the data, describe how the data is spread out, describe how skewed the data is. So the common measures of central tendency are mode, median, mean, range, standard deviation, and variance. So the mode, which is not often referred to as a mode when you do stats for social science and ed research, it's usually simply referred to as a frequency. Tells you the most frequent category or value, right? If you're thinking about, who likes which ice cream flavor, and you ask 100 people and 73 people say chocolate, then 73% is the mode. 73% like chocolate, chocolate is the mode. Modes can be calculated for all types of variables. Nominal, again, those are the categorical variables with no response. So ice cream flavor, totally categorical, no order to them. Ordinal, highest degree earned, there's an order there, or interval, purely numeric. Then there's the median. This is the category or value that lies in the middle. This can be calculated for ordinal and interval. You need an order to determine what's in the middle of that order, okay? Then mean, this is your average value, okay? The range is simply the lowest to the highest. Sometimes it is reported as two numbers, two values. Sometimes it is reported as a total. So if you survey 100 people and you ask them how old they are, and the youngest person is 21 and the oldest person is 60, the range could be reported as 21 to 60, or the range could be reported as 39. If you ask people what their highest degree earned is, and you have one person say an associate's, and then everybody else has various college, bachelor's, master's, and the highest is a medical degree, then the range is associate's to medical degree. The standard deviation is a statistic that can only be computed in conjunction with the mean, with the average. And it tells you on average how much each data point is dispersed around the mean. So this is telling you how valuable and reliable the mean is to describe the data set. If the standard deviation is a small number, it means that most of the data is right around that mean value. If the standard deviation is very large, it's telling you there are outliers in the data and that there are some values that are far away from the mean. Okay. And the variance is basically a summary measure of the standard deviation. The standard deviation is telling you on average how far each data point. The variance is telling you collectively how far are all the data points together. Okay. In SPSS, you would go to analyze descriptive statistics, and then you would go down to descriptives. Sorry, this screenshot should show you descriptives here. Sorry, we're on descriptives here. Sorry, skipping through some frequencies here. Measures of central tendency, as I said. So these, again, are talking to you about this notion of distribution, dispersion, deviation. Okay, so you've heard us talk about outliers in data. You've probably read about that. A prime example of data with outliers would be income in the United States. If you were to ask everybody living in the United States how much they make, most of the data would be towards the left side of the plot, but you do have billionaires, right? They would be far, far outliers. So descriptive analysis can tell you about variability, right? Data that is normally distributed looks like this, sometimes referred to as a bell curve, right? The median, the exact middle value, is the same as the mean. And most of the data falls within one standard deviation. This first small arrow at the bottom, both ways, that's one standard deviation above the mean and one standard deviation below the mean. This next middle length arrow is showing you two standard deviations above the mean, two standard deviations below the mean. And the longest length arrow is showing you three standard deviations above the mean and three standard deviations below the mean. In a perfectly normal distribution, the amount of data above the mean is the same as the amount of data below the mean. Okay, so again, you're going analyze, descriptive statistics, descriptives. Okay, and this is where you're going to pull in the variables for which you want to compute things like the average, right? The mean value, the standard deviation. In order to do that, you would select this options button. Okay, and a new dialog box would come up, and you should select mean, standard deviation, variance, range, minimum, and maximum. You can also select these two distributional variables, which gives you a sense of whether or not your data is skewed. Okay, we're going to go into SPSS now and walk through this. Again, frequencies and crosstabs can be computed on any variables. Those nominal ones, race, ethnicity, sex, religion. The ordinal ones, highest degree earned, socioeconomic status, lower class, middle class, upper class, right? And the intervals, the inherently numeric variables whose information can be ranked, can be ordered. There's distance that can be calculated between them, right? Frequencies and crosstabs can be computed on all of that. Measures of central tendency like mean and median and standard deviation and variance can only be computed on ordinal and interval data, on things that have an inherent order to them or things that are purely numeric. So now what I'm going to do is I'm going to go back into the SPSS data file for you. Here we go. Okay, so let's now calculate the measures of central tendency for the parents' level of education, GPA, and SAT math. So we're going to go analyze, descriptives, descriptives. Okay. Let's move in dad's education, which remember is measured in years. Mom's education, let's pull in SAT verbal, and let's pull in GPA. Okay. Now let's go to options. All right. In that box, let's click variance and range, and we will click continue. Let's paste this. All right. Go back to our syntax file. We'll put the label on top. So we'll say code to compute descriptive statistics, mean, standard deviation, range, min, max, variance for parent ed. What else do we have in there? SAT, verbal, GPA, period. All right. Let's highlight our code. Remember, the code always starts with the command, which is in blue, and ends with the period. So let's highlight our code and click the arrow. Here are our descriptive statistics. For descriptives, no matter how many variables you put in, they will all be summarized to you in one table. The table has the N, the sample size, right? So there are 7,128 responses for dad's ed, 8,296 responses for mom's ed, 1,406 students who gave an SAT verbal score, 6,232 students who gave you a GPA, and across those four variables, 1,219 respondents had data for all four. Okay. Now, the thing that we will talk a lot about as we move forward is when you are looking at one variable alone, the way that you treat sample size differs from when you are looking at variables together. If you want to analyze multiple variables together, you want to see how they correlate with each other. You want to see if one causes another. You want to see how a mean breaks down by groups based on another. You can only do that for rows of data that have complete information across all the variables. Okay, so here is your sample size. Here is your range stat, which is simply the maximum minus the minimum. Here is your mean statistic. Here is your standard deviation, and here is your variance score. Okay, this is simply your average, right? So in thinking about this, if parent education is measured in total number of years of education, dads have a little bit more education than moms, right? The average SAT verbal score appears to be about 500, right? The other things that I want you to take note of here. For the transcript, the minimum is -9 and the maximum is 417. Can you have a negative value on your transcript? Well, the first thing I would do to try to get a handle on what that means is I would go back to our code book, which let me open the code book for a second, which appears to have closed. And let's look at that transcript GPA variable. So we'll scroll down, dad ed, mom ed, SAT verbal, SAT math. Here we go, GPA. All right. So a -9 means no courses with valid credits and grades. So this is based on transcripts. A -8 is that they only had pre-high school courses. A -7 is no credits earned. A -6 is no courses taken, right? And then a 0 corresponds to a GPA of 0 to 0.99, so 0 to 0.99. right? A 100 corresponds to people whose GPA was 1.00 to 1.99. So what this is actually telling me is that we should probably recode this variable. So this variable is currently saying it's distinguishing people who didn't earn any credits at all because they didn't take any classes. It's people who didn't earn any credits because they failed everything. It's people whose credits were pre-high school only. It's people who didn't provide a transcript, as well as people whose GPA was between a 0 and a 0.99. I would argue analytically, it's probably fine to treat all of these people as zeros. So we're going to go back in and we're going to recode that variable. So we're not going to create a new variable. We're going to recode in that variable. So we're basically going to say everything that is less than 0 is going to become a 0. So if you recall, when we are transforming data, recoding data, we go transform, recode into same variable. Okay, let's pull in that. So let's reset this first. Let's pull in that GPA variable, transcript GPA. Let's go to old and new values. So you can do a range. All right. So I would say if you recall going back here, it's -6, -7, -8, and -9. All right. So let's say range -9 through -6 becomes 0. Okay. So we are taking all of the negative values reported on that variable and recoding them as zeros. We are treating all of the students who didn't earn any credits and who failed basically as the same. We're going to click continue. You can paste this again. Let's go here. Let's put our notes. So this is recoding GPA variable. So all responses that are less than or equal to 0 equals 0. All right, let's highlight that. All right, so now let's rerun our descriptive statistics. We'll keep it exactly the same. We'll click OK. And now our transcript GPA, right? The range is from 0 to 417. So all the negatives are out. So the range changes. The mean changes a little bit, but it doesn't affect it. Likely, in all likelihood, because the number of people who had negative values reported was probably very small. It changes the standard deviation a little bit and the variance a little bit. Okay. Now, the syntax file, you can simply save as, put it wherever you want on your computer. Okay. Label it whatever you would like to label it. Same thing with your output file if you want to go back into that. In your output files, you can also click on the titles of the tables and put notes in there as well. The SPSS output files, I will say, are very helpful in that you can put notes in them and you can annotate them. I will be posting on Brightspace the syntax file for your use. I will also be posting the output file if you also want to go over that. And like I said, I will be posting some ungraded practice assignments on Brightspace that are simply going to ask you to walk through what this video just did, right? Computing a new variable, adding some value labels, running some descriptives, some frequencies, some crosstabs. There is actually one more quick thing I'm going to show you guys, and that is in terms of the data file itself, in the variable view, if you want to change the variable names because these alphanumeric ones are annoying, if you will, you can simply click on that cell and put in pub ID. right? Or ID num. The only thing is that variable names cannot have spaces in them, and they can only have alphanumeric characters. So they can't have like ampersands and hashtags. And if you want to designate a space, you can just do an underscore. So now that you have ID num in your data view, oh, sorry, data view. At the top of that column, instead of saying R00000100, it says ID num, right? So you could go down the full list and rename things as you see fit. Sex, right? Month, DOB, that kind of thing. All right, and simply just save it. Okay, I will also be available for office hours tomorrow, early next week, actually throughout all of next week, if people want to meet with me and go over this stuff again. Okay, thank you.